Hi, today we are discussing ordered samples without repetition. So let's get right into it then. Let's see what are ordered samples without repetition. So in this is used in combinatorics and refers to the selection of a specific number of objects from a larger set in a specific order without allowing any object to be chosen more than once. So we're selecting a specific number of objects from a larger set and the order is important and we can't choose any element, any object more than once. Let's begin with an example. Suppose we have a set A with n elements. Okay, A is equal to set of all 1, 2, 3 up to n, and we are asked to pick k number of elements from it, but no element is allowed to appear more than once. So how many possibilities are there? Let's find out then. Clearly we have n possibilities to pick the first element, and we have n minus 1 possibilities to pick the second element since the first element can't be used again. And again, to pick the third element, we have only n minus 2 possibilities. So generally by the multiplication rule, that says that if an event can occur in m ways and another event in n ways, then the possibility of them occurring simultaneously is m into n ways. So with that, the number of possibilities is n times n minus 1 times n minus 2, etc., up to n minus k plus 1. We can show this in the pi notation as pi of n minus I from I equal to 0 to k minus 1. The pi notation indicates the product of a bunch of terms. Here, from the value of I ranges from 0 to k minus 1, and all the values change with the terms in the brackets, that is n minus I. So let's consider another example, another case where n equal to k. That is, we are counting the number of ordered samples using all the elements in the set. So here let our set A be set of 1, 2, 3. Then by using our formula, which we saw in the last slide, is 3 into 2 into 1 or 6. So the possibilities were 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. These possible rearrangements of elements is known as permutations of the set. Our formula here was n times n minus 1 into n minus 2 into n minus 3, etc., up to 2 into 1. So this notation, this expression is called as a factorial, and we denote it by the n and exclamation sign. We call it as n factorial. So we can come up with a new formula for a number of ordered samples without repetition using factorials. That is n factorial divided by n minus k the whole factor. We commonly say it as NPR, that is number of permutations of n elements taken r at a time. That equals n factorial by n minus r the whole factorial. So let's look at an example so that this concept is more clear to us. So the question is, the given is 10 people, okay, from P1 to P10, they're named from P1 to P10. The question is, how many ways can the people be lined up in a row? So we are using all 10 people. We're selecting all the 10 people from a set that contains 10 people. So using what we just learned before, that is 10p10. That is number of permutations of 10 people taken 10 at a time. So that comes to 10 factorial. That is n factorial by n minus r factorial. Here it's 10 factorial by 10 minus n factorial, or 10 factorial. That is 362,880. So let's tackle the following question. That is, how many lineups are there if P2, P6, and P9 wants to stand together? So in questions like this, we take the objects that want to stand together as a single unit. That's what I've done here. So we've taken P2, P6, and P9 as a single unit. So then we will have 7 plus 1, 8 objects. And they can be arranged in 8p8 ways. That is, we are choosing 8 elements from a set that contains 8 elements. So that is 8 factorial ways. Again, we must remember that the 3 objects which we have made into a single one, even they can be arranged between themselves again. So they can be arranged in 3p3 ways. that is 3 factorial ways. So totally, by the multiplication rule, we can say that the number of possibilities of the P2, P6, and P9 standing together is 8 factorial times 3 factorial ways, or 241920 ways. And our final question is, how many lineups are there where they do not stand together? So we know when the case when they do stand together, we know the total number of permutations we can create from 10 people. So we subtract just that, 10 factorial minus the possibilities where they do stand together, that is 8 factorial times 3 factorial. It comes to 3386880. So I hope I was able to get to you the concepts of ordered samples without repetition. Let's see a couple of more examples, and Fatima will be there to continue the session. Thank you very much.
Hello everyone. So Adil has already explained what is ordered sample without repetition and what is the formula used in the problems related to ordered sample without repetition and some other basic concepts related to it. Now we are moving to discuss a few more examples related to this topic. So let's start. Here is the first question. Given four bands, seven floats, and three equestrian units, suppose they are going to parade down the street with the bands first, then the floats, and then the equestrian units. How many such parades are possible? So, to calculate the number of possible parades, we need to multiply the number of ways to arrange each group. We have four bands, so the number of ways to arrange them is 4 factorial, which is equal to 24. We have seven floats, so the number of ways to arrange them is 7 factorial, which is equal to 5040. Finally, we have three equestrian units, so the number of ways to arrange them is 3 factorial, which is equal to 6. Therefore, the total number of possible parades, just multiply those three numbers, 24 into 5040 into 6, which is equal to 7,25,760. Okay, that question is over. Here is another sub question. Suppose they parade with each type still sticking together, but with no requirement about which type goes first, second, or third. Now, how many parades are possible? If each type still sticks together, but there is no requirement for the order in which they appear in the parade, then these three groups can also be arranged in between themselves. That means the number of ways to arrange these three groups between themselves is 3 factorial. It is equal to 3 into 6, 2 into 1, which is equal to 6. We also know the possible number of parades with each type sticking together, which is uh, we discussed in the previous question. We have already seen the answer. So, if they parade with sticking together, but there is no requirement for the order in which they appear in the parade, possible number of parades will be 7,25,760. That is the number we have seen in the previous question into 6, which is equal to 43 lakh 54,560. And there is another sub question. Suppose they forget it and just parade. How many parades are there? So, if there is no requirement for the types to stick together or of the order in which they appear in the parade, then all the elements can be mixed together and arranged in any order. So we have a total of 4 plus 7 plus 3, which means 4 bands and 7 floats and 3 equestrian units. We add up it to 14 elements in the parade. Therefore, the number of possible ways to arrange them is 14 factorial. That is 14 factorial, which is equal to this huge number. Therefore, there are this huge number possible parades when there are no requirement for the types to stick together or the order of the elements in the parade. So that's all about the first question. We are moving to second question. Here's the question. Find the number of ways of lining up 10 people, P1, P2, etc. up to P10. if no two people from the set P2, P6, P9 can be seated next to each other. So, first you should place people other than P2, P6, P9 alternatively to answer this question so that two people from that set never be seated together. Since our condition is from the set P2, P6, P9, no two people are allowed to uh, seated next to each other. So here is a figure that shows how we can place that seven people. You can arrange these seven people in seven factorial different ways. We have already seen how to calculate 7 factorial, which is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1, which is equal to 5040 ways. Now you have 8 places to arrange rest of 3 people between these 7 people. So the number of ways to arrange them are 8p3 according to permutation law, which can be written as 8 factorial divided by 8 minus 3 factorial, which is equal to 8 factorial divided by 5 factorial, and the final answer is 336. Therefore, total number of ways to line up 10 people if no two people from the set P2, P6, P9 can be seated next to each other is 5040 into 336, which is equal to 16 lakh 93,440. So that's all about the modern sample without repetition. We have discussed what it is and how where it can be applied, uh, where it can be applied its formula, and we have seen a few more examples. Thank you.